All right, let's get the show going. Hello. Today we're going to continue on an iPad taking education. Today I was actually kind of excited about working on the actual drawing portion of that note taking. I have this up, so this is a very draft. By draft I mean very simple little drawing view that I made a while ago. So we're going to walk through this and probably clean it up a little bit. But then also what I really want to do is take this view right here, which can draw, it can render some busy paths, and I'd like to end up building a drawing view that can render in a bunch of different ways. When I was making loose leaf, I experimented with a bunch of different rendering methods, and I settled on OpenGL because it's the fastest, and the latency was a really big issue, big hurdle I was trying to get over. But there are a bunch of other ways that I experimented with, and then all of that code for the most part is lost, which makes me a little bit sad. So I'd like to kind of recreate a lot of those because some of them have benefits and pros that OpenGL doesn't have, and OpenGL certainly has benefits that core graphics and some other things don't. But I'd like to build a view that's generic. That way you can easily plug in different rendering modes into it. So it simplifies the process of actually accepting all of the user touch from rendering it to screen. So you can hot swap out different ways to render it to screen without having to rebuild all of the gesture code and UI touch code and all that sort of stuff. So that's what I would like to do today. Let's also look at very briefly at where this is going to fit in. Let's launch this up. So what I would like to do is have this is a layout that's very similar to loose leaf, where you have kind of collections of pages, and you open up one of those collections, then you have a grid view of all the different pages, and I want each of these to be a PDF page. Then you can jump into any of these PDF pages, scroll around. You can zoom from either fitting the width to your iPad, or you can scale down to look at whatever that PDF's physical size is according to your screen. So if this were an 8.5 by 11 and this iPad were wider than 8.5 by 11, then you could actually see the physical true size of that paper. But then each one of these I want to be able to draw on. So that drawing piece is what I'd like to do today. The past couple of days we've been working on layout. You can switch into horizontal layout, you can vertical layout, rotate pages, and we can scale them to full width. And then we can pinch down back into grid view and pinch down back into shelf view. What I'd like to do today is work on the other side. So this is kind of the page organization side. And I'd like to also work on actual drawings. What is it called? Is Pencil Kit, right? So Pencil Kit is new as of just this past year, and I actually watched the WWDC video last night, and really interesting to just listen about the kinds of problems that they conquered in building this PK canvas view, and the focus that they had on low latency. I picked up there a couple keywords that they said. They mentioned tiles when they were rendering, which makes me think that at least a piece of their underlying rendering stack is the CA tiled view, which is also what they use for, let's see, I think, yeah, I just had it open. They have PDF rendering sample code, and copy that in here. This PDF tiled view comes from Apple, and it uses the CA tiled layer to render a PDF, a vector PDF, to a screen in really high resolution and lets you zoom in and everything like that. And it sounded from that WWDC that they're using a very similar method to render here, and they're using metal on the background somehow to render to tiles that I think show in a CA tiled view, I think, or CA tiled layer, I think. Anyway, but it was just a fascinating talk altogether, and a really, really cool technology. But one thing that the pencil kit does not do is, let's go in here and let's go to here, right? So this drawing, this PK drawing object is completely opaque, which is understandable considering kind of what the purpose of that view is for them. But you can only get a raster out, so you can save an image out, which is nice, but you can't get the underlying vector data. And there's absolutely vector data that they're using to do everything, because you can scale it really cleanly, you can export, they mark up PDFs and all that sort of thing. They have vector data somewhere, but they're just not showing it to us. And so I'd like to make a view that that does let you have that vector data. It does let you play with that vector data, and also lets you render that vector data kind of however you want. And so this current view that I have, that I played with a couple weeks ago when I was building it, renders by just creating some CA shape layers. Actually, let me okay, so I'm keep jumping around, but let's see if this will compile or not. So these PDF views have, yeah, okay, good. So it's ugly. It has a giant red border, and it has part of a red circle here. But what this red circle does is it's a CA shape layer. And so what I was testing in this is if I'm pinching to zoom, I get a nice, super crisp line there. It's not pixelated at all, which is what I really, really want. And this is happening from a CA shape layer. And so what I would like to do is use this same CA shape layer rendering, which is what I have here. And of course, there's a bunch of other different ways to render as well. But I was really happy with how this turned out, how easy it is, and how easily zoomable it is. Because what that's doing is that's a this pinch is just a transform on the view that holds that layer. So it's just a transformed layer, but you get a really nice. But anyway, so that was exciting, and so what I'd like to do initially is start by just cleaning this view up a little bit, and then maybe implementing. There's at least one rendering method here, but I'd like to get maybe a draw rect method or something else in there as well. But yeah, so that's the goal. One other thing that we can at least talk about in terms of the direction I want to go is talk about how the stroke is actually rendered right now, and what the underlying data model looks like for each of these strokes. So what comes in from the screen, from the touch endpoints, is you get points along the path that the user draws. You might also get some predicted points where the user is likely to draw next. You also get some pressure data if you're using a pencil. So And what I've also done is I have I extended a gesture recognizer here, and I've created a touch velocity gesture recognizer. So I can get a velocity at each one of these. So even though the pressure is low, I might have high velocity. Right? And so then what we can do is we can use either the pressure or the velocity to help tell us, oops. So the red here is the velocity, the blue is the pressure, and we can use each of those to determine how thick we want the line to be at that point. But before, so then we might say we might use the pressure data and say this is a really thick piece of the line, a little bit less thick, very, very low thickness. It's a lot thicker back over here. Then that stroke ends up being really thick over here, a little bit less thicker back over here. Right? And some of the ways that I've done that in the past is there's a line width property on a Bezier path. And so you can create a path and then tell it its line width, but that gives you, if you're drawing a point from here to here, you say I want a line width of 1, then it's going to give you a very simple line, right? See if I can connect those. If I say I want a line width of 10, well then it's going to give me a line width of 10, right? All the way around. But what I cannot do with a Bezier path is say I want a thickness from 5 to 10. And what I would like in that case is I would like something that grows in size over the course of the stroke. And so if you want something that can kind of interpolate that thickness along the stroke, then you have to do something else besides just the simple line width property of the Bezier path. What I did for loose leaf is loose leaf used OpenGL point rendering. And so I would feed in OpenGL, if this was my line, I would send dots very exactly spaced along that line. And for each one of these dots, I would give a texture of the brush pattern of whatever the size was at that point. Right? And then those would overlap, and you end up with something that, in this case, it looks like a solid line, but this line right here is quite literally made up of tons and tons of hundreds of little bitty dots. Each dot being the texture for that brush. And then that's what also lets me have the rectangular. You can kind of see the texture, the raw texture there it's a rectangle texture for the highlighter. So then you ping those horizontal, those rectangular textures together, and you get a nice highlighter looking texture. So that's one way to do it with OpenGL. That's obviously significantly less performant for using DrawRect or something and trying to physically draw a UI image. Times it's going to be disastrously slow, but OpenGL is super good at that. One other way I thought about doing it was if this is my line, and I knew I wanted this thickness here and very thin thickness there, then I can calculate the outer edge, that stroke, right? So here's my center line, here's my outside line, other outside line, and then what I can do is I can you can cap it off at this end, and then triangulate it. And then at the end, you have a little half circle, and this half circle can be triangulated as well, right? Called a fan. But then this can be sent to OpenGL as one object. This fan and this fan can be sent. So then you get whereas with using circles of the texture over and over and over, you end up getting a really fuzzy edge to the stroke because it's just not quite. Kind of see how the texture bounces across the path of the line. But when you're triangulating, you get a really, really crisp edge to the stroke on either side. One of the problems I had here, one of the things that I couldn't quite figure out was if I draw a stroke like this, right, where I have a sharp point and then the user starts pulling the pen the other way, then with that triangulated method, I get something that looks right over here without that center line. It ended up looking really awkward because I couldn't decide, or it was hard to tell when to draw and how much of this cap to draw. Because normally, if you have this, if this is segment 1 and this is segment 2, normally you have this is segment 1 and this is segment 2, and there's 0 cap in between them. And here you do want a rounded cap in between them. And this rounded cap you actually want to be double rendered because right here is double rendered. So if you're trying to draw a semi-transparent brush stroke, then this would be 50% opacity, this would be 50% opacity, and then you want this to be twice that, so you want that to be kind of opaque and the line cap to be opaque. And if you do a sharp right turn, then you end up having that stroke. Since they meet at the midpoint, you end up having a stroke that looks like that. And so then it becomes really gross to figure out what that intersection should end up drawing like. Make sure that the opacity looks really. So for fully opaque strokes, this method of using a triangle strip was really, really sharp, and you could actually get down to just a nice fine point at the end. You could have a super, super sharp stroke, but it only really looked good, at least for me, with fully opaque ink, and I couldn't get a nice semi-opaque ink, which is what I wanted for loose leaf. That was difficult. And then the last way that I would like to experiment with more, that I never actually rendered this way, but I chatted with another Note app developer. What he did is he used shape layers, and so if this was his stroke and these were maybe the widths at those different points, then he took this path and shifted it out to the edge of the circle. He shifted it one radius out, and then you can attach it to the other circle here. And so then what you end up rendering is a circle path and a filled Bezier shape, which is this this outline here. And then you render this circle and this circle. And then you render this shape, circle. And what it comes out looking like is it's all filled in. And the same thing here is it looks really, really good fully opaque. You have to be careful about what it looks like when it's not a fully opaque ink. That's it's essentially very similar to this method which I experimented with in OpenGL that uses triangle strips. But then it has that same corner problem of trying to figure out when and how do you render those circles, so that way you can get a nice smooth translucent ink. So anyway, so that's a lot of what I spent time on. A lot of the different ways that I thought about and attempted to render leaf. So what I'd like to try today is to take the current version of the drawing app of this little simple drawing view that I have that renders using line width and CA layer, and I would like to use draw rect. I would like to use CA tiled layer. I would like to use, instead of line width, I would like to use like a filled path, filled Bezier path. What else? And that OpenGL code was super hairy. So, and there's like one lingering bug somewhere sitting in that Jot UI library. That is just out of my league. So maybe if I can find some help on using metal to render, maybe that would be interesting. But for now, anyway, I want to just clean up this current view, refactor it a bit so there's a separation between the touch inputs, the pressure and velocity inputs, and then the rendering. Oh, the other problem that I'd like to kind of abstract away is, and they mentioned this in the WWDC video, that as the user is drawing, right, you get a touch point here, you get a touch point here, here, and here. You also get predictive touches of where they're probably going to touch. You also get pressure data, but the pressure data is stale, and so then the pressure data is predicted here, like this. So there's this this window here where you have valid touch data and predicted pressure data, and then this pressure data gets backfilled in later as your touch continues. And so there's an asynchronous portion to, as the user is drawing, you know probably where they've drawn, but the actual stroke won't finalize until the user's way over here on this side of the section. Then you know this is done, and this is a big mark. So anyway, so I'd like to be able to abstract a lot of that away, so that way we can think about dealing with this asynchronous data problem, this model problem of how do you model the user's stroke, separately from how do you physically render that to the screen. So that way we can play with those two things differently, and any optimizations we do to the data side can just flow in and automatically update all of our rendering methods. Similarly, a rendering method can just hot swap in, and we can try out different things. That's the goal. Okay, so let's try looking at this, seeing what it even does right now, what it looks like. Oh, and by the way, so I'm calling this draw UI as the library, and everything that I currently have is open sourced here, so you can go check it out. You can download the code, and everything we end up doing will end up living there as well. First, instead of infinite view, just call this a draw. Okay. we go. Okay, so what it currently does is it just opens up. I'll show you the storyboard. Storyboard is very exciting. It has a view controller. It has a draw view. It is our custom class. And when that draw view starts, the user can draw on it. And then that's it. That is the entire view. It's just that. And so how that happens is we have touch began, moved, ended, canceled. It renders one stroke at a time, and then renders all the strokes once it kind of builds it up. And to render all of them, it removes all of our sublayers. It renders each stroke at a time as a shape layer, and it just creates a static line width. And so it's not using velocity at all. It's not using pressure, not using any of that kind of stuff. It's very very simple and right now. What I think I want to do is, I was thinking about how to make this nice, and what I think I might do, create a protocol for draw view renderer, and then what do we want to do here? Oops. Draw view. Did update current stroke. Say did update model, right? This could be a yeah, that's fine. I'm going to call it an draw model, right? That's our model. This has all of our data about our current drawing. Draw model. Will update draw model, did update draw model. Probably enough for now. Right, and then right, sounds good. Now we have a drawing view. If I set a draw model on it, it should update its model, tell whatever renderer currently attached to it. Wrong, and this will be an renderer. Right. Yeah, I think I'm reasonably happy with that. Then up here we can say properties. Right, set draw model. Why are you not auto-completing? It should autocomplete, right? Am I crazy? Oh, that's why. You're running. I don't want you to. Restart the old Xcode. There we go. Cool. We'll update to a model, right? The old model, new model. That would be nice if this, yeah, they call that. My brain escapes me at midnight, but where you're not allowed to edit a model. What's it called? There's a word for that. Anyway, it could be that. Self. Feels pretty good. Then what we can do is a layer renderer. Pretty good. Going to draw a view, our renderer class, our protocol. Right? So then what do we do after that? We take a sip of tea. All right, so we have right. Now we did. Do I not use those at all? Yeah. 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 So these two are going to move over to this guy. Yeah. We're just going to move them over cleanly like that. Tidy that up later. For now, that's good enough. Model. Okay. Okay. Finish, and I'll also want to begin stroke, probably. Maybe. Oh, begin stroke with pen. Yeah, sure. Yeah, I guess so. That will start a new stroke with that particular tool, and we can finish it. Cancel it. Right? Would be model. Yeah, let's actually put those public. Well. Here we go. Go. Fine. That's fine. Not super beautiful, but that's all right. Go. Yeah. Cancel, I believe, just nils it out because we read about it. Go, and then this. There. Right? Yeah. Model. Cancel. Honest. Oh, sorry. I don't know how loud that was. I just bumped my mic. One thing I'm not entirely sure about. Honestly, what I think I want to do is I think I want to take all of these touch methods, because then there's going to be also the there's pen stroke methods and other I don't even remember. Don't even. Anyway, touch events. Weren't there other kinds of events though? Or am I just crazy? Maybe the I think there are. I might have just not dealt with them here. There's these coalesced, and the coalesced let you kind of process a bunch in a row. So I'm already doing that. Then there's the predictive side, and anyway, whatever. That's fine. That's fine. That's fine. Doesn't matter for now. What I think I want to do is actually move all of the touch processing code into here. So then this happens. Actually, let me just undo everything we just did over here. Except that. So that stays. That's different. Yeah, this goes. We're going to move the entire methods over, so that way all of the touch processing, that way the model is in charge of processing pressure data or whatever other hell kind of data it wants to deal with. Yeah. This can go out here. That. Oh, I'm in there. That. These to the implementation. Okay. Great. Go, and then we can take here. Pen. Okay, so there we go. Right. Now the draw view has a pen tool. This tool. We have model, touches began, touches at self. this is kind of what I want, where the actual UI view itself is really dumb, for lack of a better word. It doesn't actually do anything. It just passes info around to the model and to a renderer, which actually do the heavy lifting. That, and so then we can do render will update. Oops, yeah, will model self model to model. So one thing I was thinking about doing was that. And what that would let me do was, man, what is that? Computer science cannot change data. Computer science cannot change. Immutable. My goodness, immutable. Immutable data model. Which I kind of like, because that saves me some heartache whenever we get into multi-threading, when things are immutable, because then you can just pass an immutable object into a background thread and then not care about it anymore. Your current thread can just swap it out whenever it changes. Nice. We'll do that later. Let's just get this. Let's get this working first. And then we'll probably put that in. Actually, kind of. Oh, will model self. Trying to go too fast and not succeeding. Go. Go, and then one more. Okay. Now what should happen is touches come in, says, hey buddy, stuff's gonna happen. Stuff happens. Hey buddy, stuff happened. And it does that for touches began, move, ended, canceled. Now this render business we need to actually stick over into the renderer. Let's go here. No, I don't want to stick it in there. I want to stick it in muted look. So import raw view, import CA layer renderer, import model, I guess. That's probably it. Right? And we'll have renderer. We'll call this active renderer. Right? And then here, layer. Right, so now we build our renderer, we have our view, we give it a renderer. The view is going to create a model. Do I want it to do that? I don't think I want it to do that. I don't think I want it to do that at all. let's take both of these and stick them over here. So we're very explicit about who builds what. Go. We get a blank model, give it a tool, give it a blank model, give it a renderer. Better. Yeah, we don't. I think you were a leftover experiment. You're part of the renderer. Were you? Maybe not. No. We're going to be not. Okay. Great. You don't matter. You don't matter. You don't matter. Matter. Here, what we can do? No, that's fine. That's fine. Yeah, we'll solve this problem later. We're not gonna deal with the immutability of the model yet. Okay, that feels good. So let's just run it and make sure nothing died. Nothing probably died very much. Maybe something. Oops. Oh, I know what died. We didn't initialize our strokes array. Okay. So it should have still rendered that. Why didn't it render that? We don't have a path. Okay, that's fine. Let's just one problem at a time. Right? Pretty good. Yeah, so now we don't need that business. This business. Okay. It has segments. Pretty good. Yeah, that's fine. Second segment, so it should have a path now. Oh, that's funny. here. Why does it still not have any? Yeah, because I still have the stroke. I'm still on my very first one. I don't have a path. Segments. There's my path. Makes sense. Yeah, okay. It does work. All right. I don't know why it wasn't doing that before, but now it's doing it. Great. Okay. So last bit is we take this business out and put it in our renderer here. So self render all strokes. View. 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 Great. We can actually just do that. No, I'll leave it as a separate method. That's fine. Also, render model. And that will render the stroke in the view. Fine. Happen. That is happen. There. Okay, so now our actual view that we're adding to a hierarchy just tells our renderer stuff's about to change. It updates our model. It tells our renderer that it did change. And it does that for all the different touch methods. You can set a draw model, and that's it. The model is in charge of updating our drawing stroke model data and saving our history. We have all of our vector history there. That's all that it handles, and then our CA layer renderer handles actually rendering stuff to the view, right? So now it works. Great. Separate draw view, model, and renderer. Pretty good. So now what I would like to do is we have one rendering method. I would like to make a second one. Be a draw rect renderer. Right? But in order for that to work, so this is something I'm curious about. I think even just implementing this drawRect method, even if it does nothing, I think if we just implement it, that can cause some bad business. So what I might want to do instead of that is in here, oh, I think I want to put it here, right? So in the same way that the CA layer managed its own sublayers, it actually stuck them straight onto the view here. What I want to do is leave this draw view empty. Instead, if super view self canvas super view draw view, and leading anchor constrain equal to anchor. There we go, and we'll just stick it in there. There. And so now what that does is, if we're using this renderer, we build our own view. This is going to be that needs display. Yeah, that's fine. You get a, maybe there's a better way to do this. And by maybe, I mean there is, but this is fine for now. I don't not like this, I don't like it. Actually, this is going to be Yeah, this is a concrete class. Sorry. Sorry. Go. And here, implementation of that class. Rect. We're going to have a canvas view. Yeah. Okay. Oh gosh, you know what would be really nice? Since this guy is just implementing a protocol, he can just be the view himself. Right? Go. Go. And we loop through just like we did. There. There we go. So we don't have a canvas anymore because we are the canvas. Be the canvas. Great. Okay. Pretty good. So now in our view controller, we have our CA layer renderer. Also our rect renderer. Now we should be able to get essentially the exact same. No, that's gross. That's wonderful. Wonderfully gross. What did we do wrong? It should show the exact same thing. You need to clear the context, do you? I don't think so. Oh, path is nil. That's fine. Yeah, okay. Don't think we needed that. I think the maybe it defaults to opaque. Does opaque default to yes? I think it does. Yeah, default property is yes, so that's why. So we were opaque. Yeah, so there we go. Hooray! Hooray! Cool. Draw rect renderer. What other kind of renderer do we want to do? The one thing we can do is that'll need a bit of fancying. Is right here. We update our model. So actually, this should actually go here. One. One thing is we did update our model, and we do set needs display, and this guy is ignoring. It's actually updating the entire screen, right? So this entire screen is getting redrawn every single time. And if I'm just drawing over here, I'm still redrawing all of these lines all the way over here. And right now it doesn't matter because I've only got what, like 30 or 40 lines. But if I had 30 or 40,000, or I don't know when it would start to slow down, but eventually it would start to slow down and get gross. And so it'd be nice if I could just, if I'm drawing over here, it's going to tell me that my draw rect or my set needs display is only in this little area. And then I don't have to actually render all of this stuff over here. I can only render whatever strokes intersect with this rect. That would be nice. So let's try and do that. So how do you spell naive? Naive, right? Is that right? Yeah. A great speller. Okay, let's do that. Why Xcode can't rename things, but it can't. Here's a naive draw rect renderer, and now let's build a new one that is weensy bit smarter. Smart draw rect renderer. View. Right? You're going to be the exact same. And go. Go. There we go. Cool. Great. So now we have a smart one, and we need to fix this guy so it's set display rect, and we need to figure out where this guy comes from right here. And to do that, we need a little bit better model. How you doing, sir? I'm going to butcher your name by accident, but it's Saham Adavi. Pretty good. I am building something. I am unfortunately using Objective-C. I'm not using Swift. I have not yet learned Swift either. I can read it to some degree, and if I have to code it, I could probably code a little bit of it. I've been doing Objective-C though for a very long time. So that's where I'm comfortable. But yeah, today we're making a little drawing view that has a bunch of different rendering methods or ways to render what it is you draw on the screen, so we can kind of compare and contrast them. So first one, using layers. Second one, we're using DrawRect. And our third one, we're going to use a smarter DrawRect. And that's what I want to do right now. And so right now we have draw model. What I think we can do is if draw model, if we have a current stroke, right? Otherwise, we just finished our current stroke, right? And if we just finished it, then it's going to be the last stroke, right? Which means we can have draw model, stroke, draw model, strokes, last object, right? So what this does, this gets it if it exists. If it does not exist, then it gets the last of the strokes. So if we have one, right, I think we gotta have, we want path bounds, I believe. Let's look at that. I will teach some of the basics. I am trying to go through the idea of how each of these renderers works. If you have any questions as I'm going through it, definitely shout in the chat, and I'm happy to add more detail. Because I am trying to talk through as much of the basics as I can, but I also don't know what's obvious for everyone and what's not obvious for everyone. Sometimes I make really terrible assumptions. So yeah, just shoot me a question. Just ping in chat if anything does not make sense. So let's do one last thing, and then I will const k stroke width 2. And then this path bounds equal cgrect inset path bounds. Okay, so this is a nice one. Let's not show that and then see if this breaks like I think it will. No, I do not teach Swift, and I don't think you'd want me to, because I don't know enough of it to be dangerous. Right? I know just enough to be dangerous, and so I would probably teach you really, really badly. And you don't want that. Oh. Yeah. So we're doing the. It's still using our other renderer. Let's upgrade to our now super smart DrawRect renderer. So now it should. Yeah, so see that? See how it's chopped off on some of them? You can see on the bound, this one's a perfect one actually, because I drew a circle, and at the top, left, bottom, and right edges of that circle, it's cropped, right? And so that is because, if we go back over here, when I draw this circle, with a width of 10, it's actually filling in this right here, right? But the bounds that I was looking for, that I told it to update, because I told it I only need to display in the bounds of my path. And the bounds of my path is right here, right? Which means all of this is not getting rendered to screen, right? But we are successfully rendering only inside of there, which means all of this stuff is not being re-rendered because we know it has not changed, which is great. So now what we need to do is we need to pull this box out. That way we render everything inside of here. I am using all of the ugly colors today. But anyway, so hopefully that makes sense, because if this is my path, then only this box is going to be rendered when it actually fills outside of that box. Here, 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 right? And so that's what this does right here. Is we tell it to grow that that rectangle by our stroke width. And I think technically we could probably do like stroke width on 2, but the stroke width is small enough comparatively that what that's going to do is that's going to push our rectangle out, so that will get redrawn, and then all of the stroke will get rendered. Now we go to yeah, so now everything renders just fine, right? Objective-C from C. So the nice thing about Objective-C is if you know C, everything still works. It's I forget what the correct terminology is. It's not a superset C. I don't know. It's basically C plus a bunch of other stuff. And so you notice all of my syntax looks like this, where it's object, method, parameter, and then method, other, parameter, right? And so it has a strange syntax, and you can also do object getter method like that, or you can do object dot getter method like that. Whereas in C, you're probably going to do like something that looks more like that, if I remember at least a little bit of my C. But you can still do this kind of stuff. You can't do it with Objective-C objects, but if you have other C code, all of that C code works just fine. And there's actually, let me see if I can pull it up. I don't know if I have too much in .ui. So I have no. Somewhere I do. In Looseleaf I used Objective-C++, which is, you can use all of C, you can use C++, and you can use Objective-C. So you can just kind of mash all of those things together, which gets pretty ridiculous pretty quickly. I'm trying to remember what I used that for. I think I used it for the clipping, for Bezier path clipping, maybe. Yeah. So here we go. So here is a if you write C code or if you write Objective-C code, then all of this starts to look familiar in terms of syntax, right? So you have normal method calling or normal function calling kind of stuff. yeah, you have C error and C out and all that kind of business, pointers, all that kind of stuff. So all of this code compiles into my Objective-C project, and then I can still use it in Objective-C, and I can call it from Objective-C. So this method is called, which one did I use? Probably used a bunch of different ones. But then inside of this Objective-C class, I can call out to those functions that were defined in C and C++. That I think is really one of the benefits and one of the powers of using Objective-C is you can really start merging other C libraries that are already out there that do some really powerful things, and you can drop that code in, pile it in, and it just works out of the box. I imagine that's possible with Swift as well, to some degree. I'm just not entirely sure how that is, but I feel like I've heard of that before. Anyway, so now getting back to what we just did is we saw we fixed that issue where it was clipping the side of our rectangle, of the bounds of our path that we're doing. But even though we're still only rendering the box around our path, we're still sending draw commands for all of these paths out here, even though they're not being rendered at all. So this call right here is still costing us something, even though it is never intersecting with this rect, even though this rect is much smaller and is not drawing it. What we're going to do is we can do if we have a path, and if rect intersects rect, path bounds, and rect. Right? Now what this should do is, let's bump this back down to 2 so we don't have a gigantic marker thing looking at us. So now what this should do is this should say, oh, I think I think this is still slightly wrong because of the same problem here. So if that's our rect right there, and we have some other stroke like that, that's very, very close, right? So here, the inner line is our path. That inner line's bounds. This guy does not intersect with this guy, right? They do not touch at all. And there's gap. And yet, this stroke actually does intersect right here. Use another color, right? And so what we want to do is we actually want to grow this box as well to encompass not just the center line of the stroke, but the outer line of the stroke. So we want to do the exact same thing. There's path bounds, and then here we have path bounds, right? And then now we should be doing the right thing. Oops. So now what's happening is we launched. As I draw, even if I draw really close to something, everything still draws. Let's go ahead and bump up the width a little so we can really see what's going on. Right, so even though I'm very, very close to this edge and this edge, there's still they're still rendering just fine. Right? The one thing that I don't quite understand is that right there, and that right there, and that right there. Why is... Oh, okay. That's interesting. So because that's a function of using line width. So can y'all see that on the screen? So let me restart it so we get a blank canvas. Oops. There we go. That one shows it really well, where it's there's a little white spot inside of the edge of that stroke, and here it's clipped a little bit. That one's really hard to see. There we go. That one's really good. Right there, where it looks like it's half of a stroke. So what's going on there is a function of using line width. So what's happening is if our path is this, let's use black. That's our center line. We'll use blue for the line width, right? So this is what it's filling in when it draws, right? But what if my center line goes like that? Or if you notice, there's a very small bunch right there, very small right turn. That's going to do. There's that for that tiny right turn, and then once I take a sharp right turn, it goes like that. So then it ends up filling that. You get a very strange edge right there, and because most Bezier paths, when you render, oops, black for the center line, right? So if that's your path and you have a hard right angle with a big with big edges on both sides, I am not from Khan Academy. I'm just a programmer who has wrestled with this particular problem, and so I love it very much. And I also love telling other people about it, so it can be a little brain worm in their brain as well, and eat at them at night as they lay awake worrying about this problem, like I have. So if you have a large right turn there, then what it does is it renders that, and then it renders like that. But then there's a property called line cap, and line cap affects how if it rounds the edges, if it rounds corners. I think there's some other property that affects that as well. Or it might end the rendering at exactly the edge. It might square it off but be a little bit taller, or it might round it, or it might, there's a couple different things it can do, but all of those are what affect. So on a rounded one, I think it's rounding this, and so that's why it looks like only one corner is missing, right here and right up here, where it looks like one corner is missing. I think that's what's going on there. So that is a function of of using line width to render our Bezier paths. Let's do one more. Let's do make a property here Sign. Cool. Let's do filled path, right? Void render stroke. Oops. Render stroke. And then we'll take, yeah, we can take this guy, come down here. Self model stroke, right? And then up here, we can do the same thing. Now we're just going to render that stroke so we don't have to duplicate all of this code. Now our draw rect is a lot simpler. In rect. Nope. Okay. There we go. That work? Do we have any build problems? No, we're okay. Okay. So now what we can do is we can do if self filled path, otherwise, so this is using line width, and this is going to use a filled path. Let's toggle that over here. Here we go. I sound like the dude from Khan Academy. Well, that's awesome because that dude sounds amazing. His videos are fantastic. Man, I wish I had Khan Academy when I was going through school. Because that stuff is super cool. The amount of content that's on there and how good a teacher that guy is. He's awesome. What's his name? His name's Khan. His last name, obviously, but like. Starts with an S. Something. Yeah. Yeah. Solomon. Solomon? Is that how you pronounce it? Like Solomon almost? Solomon Khan? No. That's a different guy. Khan Academy. Yeah, Sal. Okay. Yeah, it's the same name. Yeah. Yeah, that guy's awesome. Okay, so now we're going to use a filled path, and we're going to do this a little bit differently. So there's a, oops, that's the wrong button. Here's our path, CG path called get path, not get path bounding box. That's a really interesting method too. I'll tell you about that in a minute. That problem has kept me up. I think that's what I want. I think. Pretty sure. Path, CG path, nil, line width is K, stroke width, CG line cap, round. Yeah, okay, so CG line join, round, and meter limit. Okay, stroke width. I don't remember what meter limit is. Anyway, line cap and line join. That is so that's line cap and that's line join. So you can make those look different. So what this guy should be doing is CG path ref call it wide path. Yeah, so that filling the new path draws the same pixels as stroking the original path. And so what we can do is path with the CG path. We're going to look at the wide. Let's actually do wide path bounds. Path bounds. If I have a path, stroke. Right, and we're actually going to do ×3 just so it's easier to see. So what this does is it has what we're giving it is we're giving it our path. We're asking it for this path by creating a copy by stroking the path, and so then it's going to give us back this path where it starts at some point and it actually has path elements that trace all the way around and give us a closed shape, and then it's going to give us that shape. And so when we draw, what we've done here is we're just still stroking the outline of it. So now we should, when we draw, get an outline of a stroke. I hope. Oh, it crashed. Wonderful, wonderful. Exception breakpoint. CG path must be non-nil. Yeah. Oh. There we go. Can't copy a nil path. Yeah, let's try again. Yeah, stroke with the 2. Great. Great. Yeah, there we go. There we go. Same thing here. I accidentally only rendered the in process stroke, which is not quite what we want. But there we go. So now you can see that what that function does is it gives us the outline of what we're drawing, right? And it's clipping a little bit because I multiplied by 3 and because we're not insetting our rect by 3. But you get the idea of what's happening here. So if I just give it a regular width and then fill, right, then that is going to give us a different. Oh, we don't need this. We don't need that. There we go. Now if we do a size of 10, I think we might have the same. No, because I did, yeah. I did a round cap. What are our other options? Line cap. I think that's right up against it. Line. Bevel. Maybe that one. No, it's angry about those. What did I do? Oh, I used the wrong one. CG line cap. CG line join. Not CA line cap and CA. Yeah. Okay. Yeah, so it still has that that strange rendering thing, and I think so. We can get around that by using a different end. What if we did set line width 0.5 and I might be wrong. I had thought that maybe no. So that's a really good one right there. You can really see what's going on in that one. That one looks like this. Oops, well, that looks like that. And then if I continued the stroke to the right, it would have looked like that, which is why that corner is missing. Yeah, so it would have looked like that, I think. Basically 2 lines right there. I think that's what would have happened. Anyway, yeah, so that's why that corner is missing even when we fill it. And so the only way to get rid of that corner is by changing the line cap. We change the line cap to square or round or anything else, then everything is fine. And the line join to round. But anyway, that fill. So now we're filling that path. Here we're stroking along the path, and here we're filling along the path, but they both end up giving the same results. Yeah, that looks good, right? And the other thing, there was that one other method I wanted to talk about real quick. It was a CG path. How's the bounding rect? Bounding box. Yeah, so this is, yeah, that gets it from the context, and that gets it from the path. Get path bounding box and get bounding box. What do you think the difference between those two things is? Path get path bounding box. Smallest rectangle completely enclosing all points, including control points. And this one is not including control points. But both give a rectangle back. The one thing that that was really on my mind when I was building loose leaf was, so this path right here, there's a couple different ways. Well, first let's look at just a Bezier path. So if this is my path right here, then to get that path, there's this endpoint, there's this endpoint, but there's also 2 control points sitting out there. Those control points are tangent to the line at the endpoints, and they help determine kind of how far out that curve goes. So there's really, the definition of this curve is 1, 2, 3, 4 points in space, 4 points on the plane defines what this curve looks like. So those bounding box methods for this curve, there's these points, So one of the bounding boxes is this one, includes all of the points. Another one is this one, which does not include all the points, right? And then another one, which they don't do, because right now they only return, or the API only returns CG rect, right? So they're rectangles aligned to your coordinate system. But there's another one that is the smallest possible rectangle, which is that one right there. And so one of the problems I had in loose leaf that I was trying to solve was, if the user draws this and for some reason I needed the smallest box because I'm rendering that down to a texture, and so I could either render it to this texture, which included all the control points, or to this texture, which included not the control points but all of the line, or to this texture, which included just the line and nothing else. And then so if I render it to this texture, then I can render it to that rectangular texture and then transform it and view it on the screen. And so this uses maybe like 20% of the memory of the blue one, right, or of the red one. So you use just dramatically less memory if you can find the minimum viable rectangle for any given path. And I'm sure there's a mathematical solution, and I couldn't quite find. I found a bunch of other math things for Bezier paths, but I couldn't find a really clean, simple, algorithmic mathematical thing to give me this box, or to give me these kind of 4 points for the box. So what I ended up doing, a little embarrassing, but pragmatic, is you take that line and then you just rotate it by 1 degree, 90 times? Not 90. Yeah, 90 degrees, so 1 degree all the time. And so then you get that, and you get that, that. One of those 90-degree turns is going to be best aligned with your screen, with your coordinate system, and then that will actually get you effectively the minimum bounding box size. And then you can untransform it to which degree it was. So you know, oh, the one at 37 degrees gave me the smallest area of the box, and so then I can transform it backwards by 37 degrees to put that texture back in the right place. And that was a real nightmare to do. But anyway, the stuff we did today was pretty fun. So we did. Let me push this code up. Status. We had a new drawRect renderer with options, right? And so all of the code for today is available at that URL, at the DrawKit URL. We have, let me pull it up on GitHub so you can stare at it in all of its beauty. That guy. So this repository right here is what I was working on today, and it is a couple different classes that I want to be fleshing out over the next days and weeks, years and lifetimes, of different ways you can render drawing on the iPad. So Apple recently came out with Pencil Kit, which is a super cool way to render pencil drawings or finger drawings or anything else on the iPad. It's super fast, has great tools, has really neat things, but it does not give you access to the underlying vector data. It only lets you export out a rasterized image, as far as I could tell. Everything else is pretty opaque. And so what I had done in Loose Leaf, which is a note-taking app that I made a bunch of years ago, is so this is also fully open source. It's a note-taking app for the iPad I made a long time ago. But this guy uses OpenGL for rendering. And there's a lot of pros and a lot of cons, and I talked earlier today about kind of some of the different ways you can render in OpenGL. But during that process of learning, I built 5 or 7 different ways to render drawings in a view. And then since I settled on OpenGL, all of that other code just kind of fell off the wagon and into the trash can. So I lost a lot of it. So what I'd like to do on this project is build a lot of different renderers and kind of re-implement a lot of those different things to show their different trade-offs and how easy some are and how hard others are. So today we worked on a renderer using CA layer, and what that does is that uses shape layers and adds those and fills those. We also used just the drawRect method of a UI view. And then the last thing we did was use that drawRect method of the UI view, but then we only drew into the rect that needed drawing. So we could set display only where the user was actively drawing, and we wouldn't have to re-render the entire view. So the performance difference between this drawRect and this slightly smarter drawRect is pretty significant. But both of those are still a lot slower than the Apple pencil kit stuff. And so what I'd like to do coming up is do fancier drawings where right now everything is a single width. So I'd like to do variable width and accept pressure inputs and velocity inputs and potentially opacity, and show which of these handle opacity better or worse or different or anything else, and some of the trade-offs there. Or brush textures would also be a really interesting one, where you could have a highlighter texture or a pen texture or a paintbrush texture, and how that could be handled. But anyway, yeah, so feel free to check out the code. It's on GitHub. And I think I've been on for an hour and a half, something like that. So I think I'm going to call it here. But appreciate you guys hanging out, and we'll do it again maybe tomorrow, maybe next week. I don't really know. I'm just kind of doing this flying by the seat of my pants, if I can any given day, or if I can't. But I enjoyed it today, and thanks for hanging out, and you guys have a good one. Bye.